Now we move on to the data quality. Okay, poor data quality negatively affect many data processing efforts, right? So always, if you remember in data understanding, remember always try to link back to crisp DM, especially if you are doing FYP. I think this can be very useful to you. At least you know what you're supposed to do. So in data understanding, as mentioned yesterday, you need to report about the quality of your data. So today we're going to talk about data quality, their issues, and how we can treat them. Okay, so data mining example, classification model. Later we're going to talk what is classification for detecting people, or actually we already talked. Yeah, I forgot. So you know what is classification, right? Who are loan risks is built using poor data. Some credit-worthy, in this case, candidates are denied to loan. Maybe we got some good candidates and they are seeking some loan, but because you have bad training model, you have delivered data mining model, but actually it's bad one, because during the training time, maybe you had a lot of issues inside your data. So in this case, what your model is going to do, it's going to do the bad thing because it's bad model. So it's going to be naughty model, bad model. So some credit-worthy candidates are going to be denied to have loan, while more loans are given to individuals that are default. That means they're not going to give the money back to the bank. Okay, so data quality actually plays a significant role in data mining or in training process. One of the issue is noises. Noises, what does it mean, noise? Very simple. If you look to this picture, let's say you are working on classifier to identify the handwritten digit. So people write on piece of paper or using digital format environment, then they write hand digit number, some digit number. Then you would like to build a classifier able to say, okay, this picture means value of 4. This picture means value of 5, and so on and so forth. So if we look to this picture, we can see actually it has many noises inside, right? So maybe it's a good idea before you proceed with your classification. That means you try to remove this noise from these pictures to make it easier to the classifier to have good results after all. Okay, because training the algorithm on this one, of course, is much better than this one. Okay, so you may need to do some pre-processing in this case. Of course, this is very simple example. If we're talking about house prices, noises to the algorithm mean like you see a variety of prices for the same features, for same characteristic of the house. Maybe you find same house, 3, let's say, examples of houses very similar. Same number of rooms, same number of bathrooms, same size, maybe located in same neighborhood, but the price is quite different. Right? This happens even like if you search for phone, second-hand phone, or even new phone. Sometimes you see each outlet sells a phone with different price. It can be a significant difference, right? Maybe 300 ringgit, 400, 500 ringgits. So this actually, you can think of it as noise. You are giving some noise to the algorithm. Is the price for the house should be 500K, or is it 550K, or is it 450K? You see, for same house, a lot of variation for the price. This actually can affect the house price. I mean, the prediction for the house price. So also you may need to deal with this noise inside your data set, okay? Like here, so this is just an example showing you the data in perfect case. Let's say it should look like this, okay? This is for classification. Maybe as here we are proceeding in one variable, then the data like drawing very nice shape. But in reality, actually, they may look like this. They are scattered here and there. So here you see that the factor noise is by 25, here 125. But anyway, the point is, this is the perfect case. This is the data without noise. And now you see how the data is scattered. If you take the example just now I've given you, is easier to understand, like the price for phone, where you see same features, same brand, same color, everything is same, but the price is different. Okay, so this can introduce, you can think of it as noise inside the data set, because the model is not sure what, let's say, price should be for this type of phone. Okay. How to use it? You can read about it. One example, they may look for the median price. So maybe for the same model, then you sort the values for all the prices available inside the data set. Then you pick the value in the middle and you assign it for all phones of the same type, of the same brand, to remove all this noise. Anyway, this is just if you like to know how this is done. But at least you understand noises like make the R variation inside the data set where the model may be not able to extract the pattern from the data set. Okay, like this case. Okay, notice here how it's so noisy. While here we may find the classifier, because classifier later we're going to discuss, they try to find boundary. So it's supposed, like, for example, finding a line which can be helpful to split up between these two categories. But looking to this one, actually it's quite difficult to find a boundary, to draw a boundary to separate between these two types of data, between the yellow and purple. Okay. So noise treatment, there are different ways, including cleaning and normalization to apply a regularization technique, such as dropout. This is dropout for neural network. But as easier example, like in this one, you are talking about the picture, then you need probably to find a way to remove this noise from the picture. Actually, one way you can build a classifier. Okay, but anyway, the point is you need to remove this noise. If you're talking about the house price, as I said, or let's say the phone prices, then probably you sort the prices in ascending order for all the same brand, same color, everything, then pick the value in the middle, then replace all the phone prices inside the data set with this median value, just to make sure that there's a lot of variation for the same brand, same all features, right, with different variations, just you have a single value. Outliers is also like noisy data inside. Outliers mean, like if you see this picture, let's say the majority of the people likes the yellow color, but we have only one person who likes red color, for example. Then this is considered outlier. Outlier means something that deviates too much from the data set. Let's say, for example, make it always, you see, you can reason about it. This is a good example. Let's say you have data set about predicting car prices. Okay, so car prices is known as they are newer, they are more expensive, correct? Right? Always, if you buy a car, 2023 is going to be the most expensive, let's say same brand. Then if you go with 2022, the price start to drop down. If you go 2021, start to drop down further, 20 drop further until maybe you reach 1990. You're going to see it maybe with a 3K or 5K car, right? Very cheap. But how about if my data set happens to have antique car inside? Those antique cars maybe even built not in 1990, in 1950, 1960, but the price is going to be high, right? So we can think of those antique cars, they are out of the norm for normal cars. Usually the normal thing for car price is going to be the newer car, the higher price. But now it's way old. The car is way old, is antique, yet the price is expensive. So this also can create distortion for the training algorithm because it cannot understand whether older car is pricey or the newer car is pricey, because you got some antique car inside. An antique car, usually they are just few. It happens inside a norm. The normal prices for cars, the newer, is more expensive. So what we need to do in this case, let's say you are building a model to predict the car price. Then, and you figure out, oh, there are antique cars inside my data set. Then what I need to do, I need to remove them, take them out. Because let's say my model is about predicting normal cars. It's not about antique cars, and antique cars is going to distort my model. My model is going to have been confused. It's going to be confused whether the newer car more expensive or the older car is more expensive. Okay, you got it? So you see, always if you reason, you're going to understand, oh, okay, so this is a good example actually about outliers where you have some objects or records that deviate way far from the norm. Okay? Like this example. Let's say we have two groups. We have blue and yellow. But here among the blue, we found that there is one yellow example. That means one yellow record here. So this is considered outlier, because think again, if I like to, because this is classification problem, if I like to find the boundary to split, it's going to be also might be difficult. Let's say straight line boundary. Then no matter how you draw the line, you may not be able to 100% split up correctly between these two types or two categories, between the blue and the yellow. Okay? So this is considered outlier. Any question? No question, huh? Everything is good. Okay. Missing values. Missing values also refer to the absence of particular value inside the data set. So like the example, let's say we are having records of people, and then some of them, if you remember last practical session, like we had inside our simple data set, a person who didn't report about his age, right? And this happens actually if you have done before any data collection where you print out survey, it's normal where you see that the respondent has missed out some items, some questions. So what you need to do in this case, we're going to discuss this. Having missing value inside can also affect this is considered part of your quality issues inside your data set. Okay, in order to treat them, there are several ways. Okay, as a reason of missing value, as we said, information is not collected. Maybe people decline to give their age, for example, and weight, especially female, right? They don't like to give their age. This is known about them. Yeah, so for example, if you distribute questionnaire, and then you may find that the age is not filled out, is missing inside your questionnaire. Or attributes may not be applicable to all cases, like annual income is not applicable to children. You are asking a person maybe who is still a student, okay, let's say instead of children, and then maybe they don't have income yet. So in this case, they may not be able to report about any income. Now, how to handle or treat missing values? We know now that there's issue, that we have some quality issue where we have missing values in some features, some columns. But how are we going to treat these missing values? There are several ways. So the first one, where you eliminate the attribute together. That means, for example, I went to the age column and I found that age column, 80% of the people have missed out this value. They didn't provide 80%. Imagine that I have 100 records only, then that means 80 records have no age value. Then what I need to do, in this case, there's nothing to do. Just drop out that column because the majority did not report about age. So you cannot think about other option. Just straight away drop this column, okay? Because the majority did not report about the value here. So just we assume that we cannot use this variable anymore and we take it out from our data set. Okay, we use the function call. Remember yesterday, those P4 and P5, drop. Now in this case, we use drop, right? And axis equal, oh my God, axis equal, right? There's a function called drop. Then we give the label, let's say age, and then comma, axis equal 0 or 1 for columns, 1. Yeah, good. Okay, so you need to provide 1. So you can use that function inside data frame. Or you can eliminate instances, rows. Again, we can use drop function and we put axis equals 0. In this case, instead of dropping or drop NA, if you remember there was drop NA, that drop NA can help us also to eliminate for this case. If you like to link between Python, so here you can write, this is for drop function. You can use drop function here drop NA. So drop NA is going to do what? It's going to check row by row. If that particular row got missing value for that particular record, then that particular record is going to be excluded. Okay? Good? Good. Okay. So back to the missing value. Okay, so again, we have several ways to handle missing value. You have many options. So it depends on the right choice that you make for certain situation. Okay, so we have eliminate the attribute altogether. So I've given you an example when actually you need to decide to go with this option. All right, when you have quite a huge number of missing value for that particular feature, like age, for example, probably many people did not report about their age. And then when I check how the percentage of missing value, let's say I found it maybe 60%. Okay, actually quite a huge number. Then in this case, I may decide to go with option, the first option, eliminate the attribute altogether. And the reason, the justification, because I got quite a huge number of missing value. Though you may say age is important, but for this type of data set that you have, it has a huge number of missing value. So what's the solution? Either you go with the same data set, or maybe you go and collect again the data, approach those people if you know them, then ask about their age, or maybe find another data set. Okay, but if you wish to use this data set where you have huge missing value, then it's not applicable. Eliminate instances where you decide maybe you're not going to deal with any missing value, just you want to drop those cases. So even let's say you have 100 features for a car, you have collected characteristic of the car for 100 characteristic, but yet you're not interested to tolerate any missing value. Then you may decide to drop those missing value. But if you like to drop those rows, keep in mind the size of your data set. If the size of your data set is already small, right? Because remember we mentioned first week, I think it was second week, where one of the challenges in data mining have sufficient size of data set. So if you have already small size data set, and also you decided to go ahead with option 2 to eliminate instances, then in this case you are going to make your data set even smaller. Okay, so it may not be a good option. But if you have a huge amount of data set, you have millions of records, then you're gonna maybe drop, let's say 1,000 or 50,000, so it may not make a big deal for you. Okay. Or also another good example where you may decide to drop, let's say your task inside data mining is to predict the car price, for example. This is a good example. So please write it down. You understand where this actually it's gonna be a must option. Okay, even if you have a huge data set, this also can be an option for you with this following example. Let's say you have data set about car price prediction. You wish to do car price prediction. So you must have a column about the actual price for the car. But also inside your data set, you notice that some cars have not, the person or this data set did not report about some of these cars inside your data set. So we have no idea how much they were sold for. Okay. Now, again, why in this case you may interest to drop the row for very good reason and not going, let's say, with replacement, because we still have other option. Why not going with the replacement or the other option? Because your original task, the main task, your main objective is to predict the car price, right? It's not about predicting the car age. It's not about predicting how many doors the car has, but it's about the car price. And car price for few cars or some records inside your data set have missing value. They didn't report about their actual price. In this case, it's also good option to go with eliminate, because you cannot tolerate in this case those missing value, because those cars or this data set is being given to the training model after all to predict the car price, but you have no idea about their car price for some of those records. So also you may decide to drop them. Even further, I can argue why I need to drop them, because later when we go to the measurement, when we need to measure the performance of the car, let's say I need to measure how good the prediction was. Let's say the model told me the car price is 100K. For this car, this type of car, the car price, the predicted car price is 100K. and I would like to verify to see whether my model was doing good. But I check back the data set, I don't know its actual price because it was not reported initially at first. Inside my data set, I have no idea. Then how you can measure the performance of your model? Cannot, right? So this is also another good reason why you need to drop those rows in this case. But let's say if your task is about predicting the age of the car, not the car price, then in this case, you may go with option 3. But if your main objective is about car price, and then you got some cars without their actual car price, you don't know how much they were sold for, then you may opt. This is going to be a very good option for you. Clear? Okay. Now we have also another option to go with replace, or we call it imputation or missing value. So also inside scikit-learn, we have a class called simple imputer. It's not mentioned here. Simple imputer. That one is going to do imputation. In other words, providing some replacement for those missing value. Okay. So for replacement, you have some statistics method you can go with, like median of the age, right? Or you can go with mean. So now you can refer back also to the, if you remember, there was a table, level of measurement summary table, just in the previous slide, telling you based on also the attribute type, whether it's nominal or ordinal, what type of statistics you can apply. For example, if it's nominal, we cannot go with median, like gender, okay? Or maybe color, let's say car color. We cannot go with median because we cannot sort out the colors from, let's say, low preference color to high preference color. Let's say this is nominal variable. So in this case, we cannot go with median. The only option for statistics, we can go with mode, the highest frequency, the most color bought, let's say, among the cars or inside the data set. Okay, so please, you see how it's important. So now we know data types. Okay, so we mentioned one reason why we need to know is for mapping, right? When we need to map values to those categorical, for example, if talking about nominal and ordinal, we need to know how to map them correctly. This is one reason. Another reason, if you like to go also with replacement, then you have, yes, option for statistical methods like mode, median, mean, but you cannot just simply pick any one. It depends on the case. If it's nominal, the only option available for you for statistics is mode. You cannot go with mean, you cannot go with median. If you have ordinal, then you have two options now with simple statistic, mode and median, but you cannot go with mean, right? If you have numeric variable, then choose whatever. You can go with mode, median, and so on. Okay, so you see how it's important. Okay, like when you work inside database, you need to know what column you have. Is it this integer, float, right, string, character? Because the way you're gonna query later may be different, and the type of the query, how it's written, can be also different. So similarly here, we need to know, because there are some treatment or some process we need to go through, like mapping, like replacement. So based on the data type, we need to choose the right option to go ahead. Okay? Simple, it's not difficult, but again, always reason, like why not mode, why not median? Always there's a reason behind it. You can understand. Or you may go with sophisticated method. Sophisticated method means this handling missing value in which stage of CRISP-DM? At which stage we apply handling missing value? Is it business understanding? No. Data understanding? No. Data pre-processing? Yes, right? So in the stage number 3, where you have data pre-processing, you're gonna handle missing value. Now, your modeling is still coming later for the stage number 4. But in stage number 3, you may be interested to apply data mining, not for the main purpose of your objective. Let's say your main objective is to predict the car price. The entire project you are building from A to Z is about car price prediction. But along the way, inside data pre-processing, let's say you don't have the age of the car, right? So an age of the car is not our target variable. The target variable means that the one that we wish to predict. The one that we wish to predict, we call it target variable, like the car price. Let's say we have another feature called age, and it got missing value, okay? And you wish to apply replacement. Replacement means you try to find some other value to fill up this value. As we said, we may go with a statistical method like median for the age of the car, or maybe you can go with mean. But you may even apply data mining again as a subtask for your major task to do prediction, okay, for the age in this case. So it's not your main goal objective. Your main goal objective is to build data mining model to do car price prediction. But along the way, you can reapply again data mining, use data mining again along the way to build another model to help you to do prediction for the age. So you can ask the data mining model, what is the proper age should be for these types of car to replace their age with, because they got missing value. Then based on the output of data mining model, I can replace or do imputation for these missing values. Okay, clear? So you are doing data mining for main task, but along the way, you can still apply data mining for subtask, like this one, handling missing values. Okay? Bagus? Bagus. Okay, so these ones, sophisticated method like regression imputation, k-nearest neighbor imputation, these just some of the algorithms that we're actually going to talk about later, you can apply to do prediction for the missing value. Duplicate data. Also, duplicate data can be reported inside your model, your data set, if you have duplicate data. So duplicate data, also you need to provide some treatment. The actual treatment, what you can do is you can remove those duplicates. If we remember in data frame, we have function called drop duplicates, right? Just we saw it in last practical session. So you can apply drop duplicates because you don't want to give the impression that these records you give them more weight because you keep repeating them many times, like as if you are giving the impression these records are important, or you're giving them more weight because you keep repeating them inside your data set. Okay, so also in statistics, by the way, what I'm mentioning here is not only for data mining. Even if you are doing simple statistics, okay, you have duplicate data, you need to deal with it. You have missing value, you need to deal with it. Even if you're just applying statistics, okay, not even machine learning. Okay, so for duplicate data, you may decide to drop those duplicate columns, okay, by calling the function drop duplicates from data frame. So data frame dot drop duplicates. Okay, any question before I move on? No question. Okay, then we move to the next topic. So now we talked about data types and data quality issue and how to deal with them. Now we move on into a new topic